Hey guys, so today we're going to go one step further from the last video and we're going to use the skills that I taught you to actually practice net ionic equation writing and balancing. So let's go ahead and get started right off the bat with some practice problems. Alright, so let's start with our first practice problem. In this practice problem we're going to take sodium chloride, combine it with lead 2 nitrate. Remember the 2, the Roman numeral, tells us that the oxidation state or the charge of this lead ion is +2. And it's those two are going to react to yield the lead 2 chloride and sodium nitrate. Now this is our molecular formula. Remember in the last video I said that you can balance at any point along the way, but I generally prefer to balance here during our molecular formula because it makes things later on a little bit easier. So let's go ahead and balance. Now because of the fact that we've got lead 2 chloride, that's PbCl2, we need to put a 2 in front of the NaCl. We put a 2 in front of the NaCl. That means we have 2 sodiums now. We need to therefore put a 2 in front of the sodium nitrate. And now we're balanced. Once we've got that balance, now we can separate based off of relative solubilities. Sodium chloride we know is fully soluble. It will fully dissociate into its ions, which means we get 2 Na plus ions and 2 Cl minus ions. The lead nitrate is also fully soluble. It dissociates into 1 Pb2 plus ion and 2 nitrate ions. What we're going to see on our product side is that the lead chloride, the lead 2 chloride, is insoluble. It does not dissociate into its ions. So therefore we leave it together in its solid form, PbCl2, that's going to be in its crystal lattice. And then we end up with the sodium nitrate. We end up fully dissociating because it is fully soluble, 2 Na and 2 NO3s. Now, what you see here is that we've got our full balanced ionic equation. Remember, to get to our net ionic equation, we have to cancel the spectators. And if you remember, the spectators are those that are not actively participating in the reaction. This means we need to look for things that don't change chemically over the course of the reaction. In this case, it would be the sodium ions, Na+, which are the same on both the reactant side and the product side, and the nitrate ions, NO3-, which is also going to be the same on both reactant and product side. Those will cancel. Once we do that, we end up with our net ionic equation remaining. We rewrite it, so it is going to be 2 chloride ions, Cl-, plus 1 lead 2 plus ion, and that's going to react to yield our solid lead 2 chloride, PbCl2. Remember, you don't have to put those subscripts to show aqueous or solid, but you're welcome to do it if it helps you out. So let's take a look at the next practice problem. Now, in this practice problem, we are dealing with sodium thiocyanate, Na2S2O3. We combine it with sodium hypochlorite, NaOCl, and sodium hydroxide, NaOH. They are going to react to yield, in this situation, sodium sulfate, Na2SO4, sodium chloride, NaCl, and water. So here's our chemical reaction. This is a molecular form. Now our job is to find the net ionic equation out of this. So I want you to take a couple of seconds. I want you to try this on your own. See if you can identify and eliminate any spectators, and then write the net ionic equation. If you get stuck, or if you get your answer, go ahead and unpause the video and we'll work through it together. One thing to be aware of is this question actually came from an old AP exam. These questions are really common in AP chemistry and on the AP exam, so be aware that this is something that's going to come up repeatedly throughout the year. So I've had a few seconds to work through it. Let's go ahead and work through it together. The first thing to remember is you need to balance the equation. In this situation, though, you can see it's already balanced, so that step's already been done for us. That might happen sometimes, but you can never make that assumption. What this means is that we need to move on to our next step, separating into its full ionic equation. This means we identify relative solubilities of reactants and products. Sodium thiocyanate, Na2S2O3, is fully soluble because all alkali metal salts are fully soluble. Therefore, we get 2 sodium ions and 1 thiocyanate ion, S2O3 2-. We also will take the sodium hypochlorite, recognize that it is fully soluble, We are going to separate it into its ionic components, so it's 4 sodium ions and 4 hypochlorite ions. So it's 4 Na plus and 4 OCl minuses. We then are going to look at the sodium hydroxide. Now, sodium hydroxide is a strong base. It is fully soluble as well, fully dissociates. Therefore, it's 2 sodium ions and 2 hydroxide ions. Now, looking at our products, the sodium sulfate is going to be fully soluble. It dissociates into its ionic components, so you're going to end up with 4 sodium ions, remember, because it's a 2 of a coefficient and a 2 of a subscript. So there's going to be 4 Na plus and 2 sulfate SO4 2 minus ions. The sodium chloride is fully soluble, so we end up with 4 sodium ions and 4 chloride minus ions. The water is not soluble at all. It stays together, so it's just going to be H2O. Now we've separated into its full ionic equation. The next step is identifying and canceling spectators. Now in this case, there are actually no spectator anions. In fact, the only spectator in this entire reaction is going to be the sodium ion. And that's okay. You can have just a single spectator ion. In this case, that's happening. So if you look at our final net ionic equation, you can see that the only thing we've eliminated here is the sodium ion. All right, for this next practice problem, I want you to take a look, try it on your own. If you get stuck or when you get an answer, go ahead and unpause the video. We'll work through it together. All right, now you've had a couple of seconds to work through it. Let's go ahead and go through it together. Here we're taking cobalt chloride, CoCl2, combining it with sodium sulfate, Na2SO4. The reaction yields cobalt 2 sulfate, CoSO4, and sodium chloride. Remember, you need to balance first. So in order to balance this properly, we need to make sure that we have a 2 in front of the sodium chloride, NaCl, and that alone will balance our overall equation. So we're good, we're balanced. Once we do that, we separate based off of relative solubilities. So cobalt 2 chloride is fully soluble, so it dissociates into cobalt 2 plus, CO2 plus, and 2 Cl minus ions. Sodium sulfate, also fully soluble. It dissociates into 2 sodium ions and 1 sulfate ion. The cobalt 2 sulfate is fully soluble as well. Therefore, it dissociates into cobalt 2 plus and sulfate 2 minus ions. And therefore, we have sodium chloride, also fully soluble, Na plus and Cl minus. Be careful. Remember, the coefficient comes down. So you have 2 sodium ions and 2 chloride ions. We separate these ions based off solubilities. We now look at them and say, okay, what's the same on both sides? And we cancel. And everything canceled. Remember in the last video what I talked about when everything cancels. This tells us that everything acts as a spectator, and overall, there is no reaction occurring. This is not a common problem in the AP level, but you do need to understand the relative non-reactivity of some compounds because of the fact that it will play directly into electrochemistry later in the year. So it's very important to understand that sometimes ionic compounds will not react with each other, and that's okay. But in general, in AP, anything they say will react will in fact react. So that wraps up today's video. Today we just did some practice with net ionic equation balancing and writing. Make sure that you are solid in this technique. It's a really important technique for you guys to have throughout the entirety of this year. If there's anything that's going to come up in more units than another, it's going to be this exact skill. So it's a really good skill to have down pat. I'd like to thank Sarah Hamzy, Riley Flynn, and Catherine Schilling for writing, filming, and editing this video. I'd like to thank you guys for watching it, and I'll see you in the next one.